Okay, guys, so here's the second part. And there's a bunch of these on Delta Math, so I'll assign some like this with this homework. So f of x is a differentiable function. Selected values of f and its derivative are shown in the table below. Find this limit. Okay, whenever you're finding a limit, if x is approaching a number, the first move is to direct substitute. So 2 f of 6 minus 12 over 20 minus 20. Okay, so the bottom is 0. If the top is also 0, then we can use L'Hopital's rule. So f of 6, so I'm in the f column down here. So f of 6 is 6. All right, so it's 2 times 6 in the top. All right, so then, therefore, by L'Hopital's rule, this limit equals, this limit that we've been given equals the limit as x approaches 2 ddx 2f 3x minus. Okay, alrighty. So now you look at the top and you look at the bottom. And in the top, I've got two terms that I need to take the derivative of. This one is a one-step. This one is not a one-step. If it were f of just x, then it would be a one-step. But if there is something going into the function other than just a plain old x, that requires chain rule. All right, so I'm going to have to split that up there. And then in the bottom, both of these are one-steps, so I could just leave everything alone. And then off to the side. So this would be a one-step if I let u equal 3x. All right, then it would just be f of u, and its derivative d du would be f prime of u. Okay, now as I said in the last video, whenever we take a u off to the side, guys, we want to take its derivative from now on as well. Because if you're doing a u substitution in calculus, you're going to need the derivative of it. So du dx, and then you take the derivative of that, it's just 3. Okay, so that is all ready to go. So this is the limit as x approaches 2 ddx 2 f of u. All right, and then this could just stay. Okay. All right, now I'm going to go in with the highlighter, but you could do the highlighter part in your head. So up top, all right, so that is a one-step with chain rule. And I'll just put it like here. It's du dx times 2f prime of u. Right, that's what that whole thing is. Okay, and then this one here, that term is just 6x. Okay, and then in the bottom, this is 10x minus 10 in the bottom. Okay, now before I go back into the problem, so over here, so in for du dx is going to be going 3, right? And then in for u is going to be going 3x. It's going to be going back in there. So it's going to be 6 f prime of 3x. So the limit as x approaches 2, 6 f prime of 3x. All right, plugging in 2. right, so I'm direct substituting. 6 f prime of 6 minus 12. Okay, so the bottom isn't 0. And now I got to go up to the table. F prime, all the way at the bottom 6. So f prime of 6 is 8. So that's 8. So this is 48 minus 12 over 10. 36 over 10. 18 fifths, I think